This is the homework solutions for the second week, chapter 2, which is one-dimensional motion. And we will start with number 3. Number 3 has a diagram in the book which looks something like, number 3 is a problem where you have to look at distance versus displacement. And first of all, distance, if you're going to calculate the distance, you take the 10 units, subtract 2, add the second leg, which is 10 units, subtract 8, add the third, which is 11 units, subtract 3, or excuse me, 8. And so you have 8 plus 2 plus 3, and that equals 13 units total, or 13 meters. For displacement, you have the same situation, but you end up going from 11, or from 2 to 11, and so you have a total of 9 meters of displacement. And then when you incorporate the direction, 11 is from left to right, and we're going to arbitrarily say that's a positive, and 2 is from right to left. We'll say that's negative, so you end up with a positive 9 meters, and this positive indicates the direction if you say that left to right is positive. Number 4 is a very similar problem. You start out with 9 for distance, 9 minus 3 plus 5 minus 3. And if you do the math here, this is 6 and this is 2, and so you end up with 8 units, or 8 meters. Let's say meters. B is 9 minus 5, which is your end point, or 4 meters. And then we're going to say that left to right is positive, so 9 ends up being negative, and 5 is positive, so you end up with a negative 4 meters, or 4 meters right to left. 4 meters right to left. Now moving on, we're going to move now to calculations of speed. And the first one is number 7. And number 7 states the North American and European continents are moving apart at a rate of about 3 centimeters per year. At this rate, how long will it take them to drift 500 kilometers apart than they are at present? Well, first of all, you have to take what you want to calculate is the time it takes for them to drift apart 500 kilometers if they are moving at 3 centimeters per year. So you have 500 kilometers, and 1 kilometer is 1,000 meters, and 1 meter is 100 centimeters. And then you know that in 1 year, you're moving 3 centimeters. And so when you cancel all this out, I'm sorry, this should be the other way around. Let me correct this. And so kilometers, actually I've got this set up wrong, I'm sorry. Now you see why I do this on video, so you can see how I can fix this when I make a mistake. So let's start over again. We have 1 kilometer is 1,000 meters, and 1 meter is 100 centimeters, and 3 centimeters occurs 1 year, and so this will give you the answer in years. If you do the math here, you end up with 2 times 10 to the, 1.67 times 10 to the 7th years. And since the the only measure is this 3. It's in one significant figure. It's going to be 2 times 10 to the 7th years. So the answer is 2 times 10 to the 7th years. Number 9 states, on May 26, 1934, a steam-lined stainless steel diesel train called the Zephyr set the world's nonstop long-distance speed record for trains. It runs from Denver to Chicago, took 13 hours, 4 minutes, and 58 seconds, and was witnessed by more than 1 million people along the route. The total distance traveled was 1,633.8 kilometers. What is the average speed in kilometers per hour and meters per second? So, first of all, you have to change the time to seconds. And so you start out with 13 hours, and there are 3,600 seconds per hour. And you add that quantity to 4 minutes, and there are 60 seconds in 1 minute. And then you'll add the 58 seconds to that. And if you do the whole total here, you end up with 47,098 seconds that it took the Zephyr to do this trip. So, and I took the minutes and hours, and I changed that into a amount of seconds just for the minutes and hours, and that equals 298 seconds. And there are 3,600 seconds in an hour, and that tells you that number of seconds is 0.082778 hours. And so it's 13.082778 hours. And I did that so I could calculate the kilometers per hour. So we have 1,633.8 kilometers, and that is traveled in 13 hours, 0.82778 hours. And if you do the division here, you get 124.88 kilometers per hour. And since this is 5 significant figures and this was a conversion, this is the controlling factor here. And in terms of hours, both of these have at least 5 significant figures. And so the answer should be in 5 significant figures. Now, it also asks us to calculate this in meters per second. And so we have 1,633.8 kilometers, and 1 kilometer is 1,000 meters. And we have our seconds calculation up here, so we have 47,098 seconds. And if you do the math here, you get 34.689 meters per second. 34.689 meters per second, or 124.88 kilometers per hour. Now the next problem is number 11. Number 11 states that a student drove to the university from her home and noted that the odometer reading in her car increased by 12 kilometers. The trip took 18 minutes. What was her average speed? So we have a 12.0 kilometer trip, and it took 18 minutes. Now the question here is, it doesn't specify the units here. And so you could just take 12 divided by 18, and you end up with an answer in kilometers per minute. Or, since most people usually work in terms of hours, you can take the 12 kilometers and 18 minutes, and then realize that there are 60 minutes in an hour. And if you do the math here, you get 40 kilometers per hour. 3 significant figures. Part B states, if a straight line distance from our home to the university is 10.3 kilometers in a direction 25 degrees south of east, what was her average velocity? So it's now 10.3, the straight line distance, or displacement now, divided by 18 times 60 over an hour. And now you have 34.3 kilometers per hour, but you have to also give a direction, which is 25 degrees south of east. And if you don't include the direction, the answer is incorrect, because a vector quantity like velocity has to have both a size and a direction, or magnitude and a direction. And the third part said is if she returned home by the same path 7 hours and 30 minutes after she left, what was the average speed and velocity for the entire trip? Well, speed, now you're going to take 2 times 12 kilometers, because she went over and back, and divide that by the total, which is 7.5 hours, and you end up with 3.2 kilometers per hour for the speed. The velocity, on the other hand, since she returned home, there's no displacement, so it's 0 over 7.5, and you end up with an answer of 0. And that's another one of those trick questions like the propeller question we had in class. The next one, we'll do one more on this part, and then we'll stop and move to the next part. The next one states that a quarterback runs 15 meters straight down the playing field in 2.5 seconds. He is then hit and pushed 3 millimeters straight backwards in 1.75 seconds. He breaks the tackle and runs straight forward another 21 meters in 5.8 seconds. Calculate his average velocity, A, for each of the 3 intervals, and B, for the entire motion. Okay, so first of all, we have to calculate each of the 3 intervals, and we're going to say down the field, this is number 14, we're going to say that down the field is positive and backwards is negative. Okay, so ahead is positive and is backwards. Negative is backwards. And so the first interval is 15.0 in the positive direction, and that is in 2.5 seconds. And so that ends up being 6 meters per second, 0.0 meters per second. 2 significant figures. The second distance is -3, and it's in 1.75 seconds, and so that velocity is -1.71 meters per second. And the minus here gives you the direction. This is plus, and this is minus. And then the last one is 21 meters, 21.0 meters in 5.20 seconds. And that ends up being 4.04 meters per second in the positive direction. Now for the entire interval, you would have to take the entire this minus this plus this, which is a total of 33 meters, and divide that by the total time, which is 9.45 seconds, and you end up with an answer of positive 3.49 meters per second.